Jain everybody. In this video, we would be discussing how the transaction takes place in the blockchain. In the previous video, we have discussed the components of the blockchain, then what were the blocks, how do we add those particular blocks in the blockchain. Now, for adding those particular block, obviously there should be a blockchain transaction. So these are some of the steps in the nutshell that which steps we take place while doing a transaction in the blockchain. So first is the blockchain is a digital ledger or a digital database. We should have each and every transaction which we are doing it in the digital format. We cannot have anything in the physical format. And obviously, as it is a blockchain, so we should have this particular ledger in the distributed form, that is to all the nodes. It should be broadcasted to all the nodes, or it should be the same ledger or the same digital database should exist on each and every node in that particular blockchain. So distributed is the same copy is being replicated on each and every node. That was the basic difference between the traditional and the blockchain databases. In blockchain, we keep a replicate copy of that particular ledger or the database on each and every nodes, but in traditional database, we hinder that particular thing. We are opposing that particular thing. We don't want to keep that replicated data as it is taking more of the memory. Then the blockchain is a decentralized, so there is no central authority who is taking care of all those particular transactions which is done in the blockchain. So first was the digital ledger. Point was the digital ledger. The first was the digital ledger or the digital database. Then second was that ledger is distributed. Third is ledger is decentralized, means we don't have any central authority control. So we cannot control, nobody is there, because each and every node has are equally likely to become the winner as a miner, equally likely to start that particular transaction, equally likely to update that particular transaction and complete that particular transaction. So it is decentralized. We don't have a central authority to control all those particular things. So we are doing it in the form, and all the nodes in the network are participating into whatever we are doing, even the creation, initiating the transaction, completing that particular transaction. So for each and every time, we are generating a unique cryptographic secure record each and every time. Unique as the hash code which is generated is unique. Cryptography means we are using a hash values, which is to SHA-256, that is secure hash algorithm function, which is generating a 64-bit unique value each and every time. So we are having that particular secure, nobody can track, as we have seen in the last videos, because it is having a previous hash function into the current hash function. So obviously handshaking is there or a chaining is there, and if we change something in one block, we have to change in all the subsequent blocks, not the previous blocks, because we are using the previous block hash code as the hash code for the next block. So here we will take an example. Here I have taken an example of Joe, and Joe wants to send 2 Bitcoin. This Bitcoin is a cryptocurrency which he wants to transfer to N's account through the blockchain. This is normal transaction. If you don't want to use the Bitcoin one, we can have a normal banking transaction also of transferring a ₹1,000. The steps would remain same because I am transferring some money. Here money is in terms of the cryptocurrency. So then we can compare this traditional and the blockchain transactions, how they differ and what are the steps in which it differs. So what would Joe do? Joe would request the proposed transaction, and Joe sends that I want to send. What request he would send? Joe sends 2 Bitcoin from his wallet app that I have to transfer this 2 coins to Jane. So I would be naming these 2 persons here, Joe and N. He wants to send 2 Bitcoins to N. Okay, and here if we assume I have person P1, person P2, P3 and P4 in this particular network along with Joe and N. Okay, so he has proposed that I want to transfer this, and he is ready to give his 2 Bitcoin from his wallet to N. That is the transaction. Now what? The proposed transaction is broadcasted to the network. So Joe would tell that I want to do this. It would broadcast it to everybody. Okay. He would broadcast this to N also. He would broadcast to P1, P2, P3 and P4. Okay. Now what would they do it? What would they do it? First of all, they would validate the transaction which Joe wants to do it. How they would validate? All these P1, P2, P3, P4 and N would validate. So first step they would validate the user. How they would validate the user? Is this particular user, that is the Joe, does Joe belong to this particular blockchain? That is the unique number which is being assigned to a Joe, or a unique wallet ID number which is assigned to a Joe. If that belongs to their blockchain, then definitely he is a valid user and he can do a transaction in that particular blockchain. The first validation of the user is done. Second, validation of the amount is done. Amount is what value do we want to transfer? I want to transfer 2 bitcoins. Do Joe has 2 bitcoins or more than 2 bitcoins in his account or in his wallet? If yes, then this transaction is valid. If no, then this transaction is invalid and everybody in this network will send a message that this is an invalid transaction. If the transaction is invalid, then we don't generate a block for that particular invalid transaction. We generate a block only for a valid transaction. So here we have checked 2 validities. If this is true, that if Joe has, assume Joe has 10 bitcoins in his account, he want to transfer 2, obviously the balance is greater than 2 bitcoin which he wants to transfer to N. So this becomes a valid transaction. So this has been validated that Joe is a valid user in that particular blockchain and Joe has the sufficient amount so that they can send it to N. Okay. Then miners verify that particular transactions and bundle it into a block along with the another transaction. Now they have validated this particular user. So Joe can send this money, do this particular transaction and send this money to N. While doing that particular thing, we bundle up that particular, if assume this transaction was transaction number 10 and previously I had transaction 8, transaction 9 and now the transaction 10 was between Joe and N. So this transaction is the transaction 10. So along with the old transactions, because we needed sufficient amount of transaction data to bundle up into a block, we cannot make a single block for each and every transaction. Obviously, that would be a big blockchain in a normal way. So we can have all these 3 transactions bundled up together as a transaction data of that particular block. Then bundling up all these things, they are bundling together and trying to generate a hash code. Again, while generating a hash code, we have to see that the new hash value should be less than the targeted value, which is the previous hash value. And then if that particular, any of the person in this particular chain, assume P4 becomes the winner, that is the miner. So what this miner will do? Miner will bundle all these 8, 9, 10, bundle up together, make a hash code along with the nonce, along with the current timestamp and the previous hash value and generate a new unique hash code and create a block. Then it would broadcast it. To everyone, that particular block. When this block is being transferred, now the Joe account is being minused by 2 bitcoin and N's is added with 2 bitcoin. So balance in Joe is being deducted and balance of that particular N has been added. So the miner validate this transaction which they want to continue in that particular block. So we have to see which all particular block contains all those particular transactions. Here we have seen that the status of the Joe, if it is he is a valid user or he has the sufficient account, then the miners validate the transaction and then continue to create a block. Miners usually compete to solve the complete mathematical puzzle, and that puzzle is obviously here the word, this is very important, that is complex. It is very complex because while remember that particular Markle root was having hashing and hashing. So we are rehashing and generating. That is a very complex system which is doing it. So these puzzles require very much of the computation power. So in the last lectures I've told you that we require supercomputers for solving this. We require high speed processors for doing this. This protects the blockchain against hackers, as it would be difficult and expensive to attack the network, because this high processing power would generate that particular hash maybe within a minute or less than that particular minute. So at that particular time, if somebody is listening to that particular blockchain or somebody is trying to tamper the value in the blockchain, they won't be able to do that particular, compromise the data. They won't be able to tamper that particular data, and it would be difficult in as well as expensive also for them to do that. Okay, the nodes verify the miner's work. The nodes which are doing different nodes which were connected, they would verify that the miner which has done the work is valid or not. So miner who finds the correct hash value broadcasts the block to the network. Okay, majority of the nodes of the miner needs to approve or verify the block accepted by the blockchain. Here comes the catch. SC, we have seen that P4 was the winner. So I would come again to this particular point, that P4 is the winner in my blockchain, and P4 is telling that he has generated a value. He has generated, this is Joe, this is Anne. So they are doing the transaction. We had P1, P2, P3 and P4. So P4 was the miner. A P4 has created a unique hash value, unique hash code. So when P4 tells that I have generated this unique hash code, which is obviously less than the hash value of the previous code, the condition satisfying all those things, then P1, P2, P3, Joe and N tries to compete that if can they break this particular hash code. Can they temper that particular hash code? If they are able to do it, definitely anyone, any malicious attacker coming to that particular blockchain can do it. So they, for a specific duration of time, as you see, if this particular miner has generated it in 50 seconds, if this P4 has generated in 50 seconds, then approximately 50 seconds would be given to P1, P2, P3, Joe and N, so that they see if they are able to break that particular hash code. Break that hash code means by using that particular hash value, are they able to generate the previous value? If they are able to generate the previous hash value, means definitely they would be able to do that particular thing. They can hack, or a malicious attacker can compromise that particular data. If they are not able to do it in the 50 seconds, then P4 is declared as winner. That hash value is being added along with the block to each and every, is being broadcasted. Broadcast is mean not it is sent to everybody. In the previous video I've seen, we are flooding it. We are sending to the person known to P4, then again and again it is being forwarded. So we flood that particular block in the blockchain which is being used by the Bitcoin, and this shows that majority of the users have verified that particular hash value. Okay, so what was the reward for the winner? The miner becomes the winner, and that particular miner will get the rewards in terms of money, or in terms, if this is a Bitcoin blockchain, then definitely in terms of the Bitcoin. and the transaction fee would be paid by Joe and N both, because they both are taking part into that particular transaction. So money is being paid to the blockchain by Joe and N as a transaction fee, and money is gained by the miner, who is the winner of this particular, who has created this particular unique hash value. So once that particular winning miner is approved, he would collect that particular reward. That reward would be added to its wallet app. Okay. So sixth, then we add that particular block. Once the block is verified, the winner adds the block to the existing blockchain, and then the Joe transaction is added to the blockchain along with the another transactions. The updated copy of the blockchain is circulated through the network. So this circulated is, we usually use flooding method. Flooding method is this P4 being the winner sends to some of the person, maybe 1000, and these 1000 peoples then again sends to 1000 peoples. So that is called as flooding. Okay, so these are sending to again 1000 peoples. So this process is called as flooding of this particular blocks in that particular blockchain. So how it is being circulated, we have different methods, but usually we use this method because we don't have a direct connection from P4. So if I assume P99986, we don't have a direct connection with that particular node. Maybe they are sitting side by side, but there is no connection between them. So we can have that particular flooding technique, which is commonly used for broadcasting this particular block, which is being uniquely identified. And then that particular transaction completes, the end receives the 2 bitcoins, and 2 bitcoins are being deducted from the Joe's account, and then the transaction is being complete. So the process of Bitcoin blockchain transaction is, a node in the blockchain is P2P network, obviously peer-to-peer network. It requests the transaction via the wallet, that I want to do any transaction. The transaction is broadcasted to all the nodes in the network. The transaction is validated or verified. That is, obviously we are using that particular consensus rule. Don't forget that consensus protocols which we are using, it the set of rules to verify each and everything. So here the user is verified. Once the user is verified, then the transaction is to accepted or not. That if it is user is verified, then the transaction is a valid user, then it is accepted, then the transaction actually takes place. And if the transaction is accepted, it is added. This is important in the chronological order along with other transactions which are created and sealed together, packed together in one packet, and that is called as the hash. And the transaction is now become a part of the blockchain, and it is permanent and immutable. That is, it is tamper proof. And this tamper proofness tells you it is very secure. So security is the main things which we have it. Okay. So there are some of the pros and cons which we have in the blockchain. In the blockchain, the massive potential of the blockchain is, we want that it should be decentralized, it should be permissionless, it should be secure, and obviously transparent applications, transparently used in each and every applications. So some of the significant blockchain characteristics which we have, and how that particular characteristics act as a pros also, and how the same characteristic can act as a cons also in the blockchain. We would be discussing these three or four properties are there. So one is the decentralized and the distributedness. Obviously in the blockchain technology, it works on the principle of the ledger data, which is distributed on each and every nodes, and there are not they are not in any of the hierarchical manner. No central control unit is there. Obviously decentralized is, we don't have any person who takes the rights of the distributed. It is equally likely on each and every nodes. So what are we doing it? We are removing that central point of failure, one single point of failure which was there in the centralized, or at some particular point of time it was there in decentralized also, when the network is being divided into two parts. So this is being done by replicating that particular ledger on each and every node. Even a single node gets damaged or crashed, then we can have another node which has that particular data. Whenever it gets up or it boots up again, then it can use that particular database, distributed ledger database from the blockchain, and can restart doing that particular thing. And it is better communication between the nodes, foster the transparency and faster concerns, and we have syncing of that particular data. So it allows more engagement, as everyone is involved in decision making process and keeping the network honest. So what are the drawbacks? So drawbacks is traditional, in some of the cases, traditional database becomes faster as compared to the blockchain, because blockchain has to take what was the bundle up hash value of the previous code, then the timestamp, then nonce, then Merkle root. So in Merkle root also we require some of the time, and then the transaction data. So we have to bundle up all those things. So in some of the transaction, the traditional database system acts as a faster and a cheaper one as compared to the blockchain. And they are specific and trusted third party exist in some domains. We will come to this particular point as a distributed one when we will discuss the types of the blockchain, because this is for your private permissioned blockchain. We would be discussing that in coming videos. Permission blockchain. So these can guarantee more efficient and specialized services using different technologies. So that if it is not being, we are in hindering that particular cause, because we are given equal rights. Maybe the malicious user also has the same right, and we are not using that particular domain as efficiently as we have to. So if a time tested and fully functional database, if the database is fully functional, it is not creating any of the problem, then why would we replicate or introduce a blockchain, and whole of lot of the technology would be changed, and we require more of the investment, more of the people to be hired, and do we get that particular ROI, return on those particular investment in that application which is working fine? If a server of if a banking system of assume PNB is working very fine, why would they go to this particular blockchain environment if everything is working fine on their end? Because on moving from your traditional database to a blockchain, they would require a massive difference in the design architecture. Obviously, new persons need to be hired. The application is being developed, the new person needs to be giving the training. Maybe some of the users may be reluctant to use that particular thing. So in that particular scenario, obviously, if I get that particular return on that investment, I would surely do it. Otherwise, I won't do it. Okay, those strong players may get the control of the network and impacting the decentralization. Here, the strong player means the miners. Here, the main person which comes out to be the miners. If I don't have a much computing power system, then I won't take part in mining of any of the transactions. Okay. Assume we have 10,000 people in my blockchain. If 10,000 people are trying to mine, out of 10,000, only 2,000 have that particular computing power to mine that particular transaction. So these 2,000 people become the strong player of this particular blockchain, and then they can start ruling that particular thing, because other 8,000 persons do not have that computing power on their PCs. Okay, so the computing power which is required to become a miner is being owned by only 2,000 people, and that would create a problem. Okay, so this was the first distributed and decentralized. The next one is the trustlessness. In the blockchain, the cryptography completely replaces the third party trust, because we are rehashing and hashing and doing that, all those things. The complex consensus algorithms can run within the blockchain. The network to anonymously and secure. If that particular node is being added to the new node is being added to that particular blockchain, we don't because they are anonymous user, we don't have a trust on them. We only have that they are included in the blockchain and they would be taking part in the transaction. So advantages, you can have the multiple entities or the key players which we are trusting on each other, even we don't know each other. We all are anonymous to each other. We don't know from which location in the country or on that particular globe they are accessing it. To ensure that the transactions are valid, the data is accurate, what the values they are doing it, that is 3. That is accurate. We don't require anything else, even for n number of anonymous users added to that particular blockchain. Then they have removed the need for the middleman. So obviously the middleman is being removed, so the cost has been reduced. The profit of if hierarchy is being removed, if 4% in this hierarchy is removed, then direct connection between these two persons, then obviously if this takes 0.1% also, and this takes 0.5%, approximately 1% of the cost is being reduced. So that is an advantage. But the problem is the integrity of data is obtained there, where the expense of the time is very there. We have to verify that particular transaction. If I give you example of the Bitcoin, it takes approximately 10 minutes to create one particular block. So obviously we don't require milliseconds, but we require more time to generate that particular blocks, because we are bundling up multiple transactions together. Okay, and we require a significant computing power for each and every miner, which is obviously in the last videos we have discussed, it is generating global warming. And we have to see the prioritize this transaction and give the rewards for that. Then the last pros and cons comes out to be the immutability, that is we cannot modify the transactions. So if by chance I have named in that particular transaction the name of the person has changed, then in that case we have that particular record as a permanent record. We cannot undo that particular record also, we cannot update that particular record also when it is being done. So any change required can be addressed only by adding a new block to the existing block in the chronological order, and ensure that the database is complete and consistent. So pros or the advantages are, it is verifiable, the consensus algorithm and back propagation mitigations are there, so double spending risk is not there, and there is providence, that the ability to track the transactions or product movement across the accounts. These particular things, advantages can act that we can use this in the supply chain management system as an application. And the cons is, not every node has the capacity to maintain or run the full copy of the blockchain, as we have seen full node and the partial nodes. So partial node keeps only the header because of the space, and the full node keeps all the transaction histories. So these are some of the disadvantages. Here we can have a 51% attack also. If some of the users always become that particular miners, then they try to rule that particular miner. In the coming videos we would be discussing about 51% attack in detail. And the quantum computing potentially breaks out, and we have to reserve the engineers specifically for generating the public key and the private keys. So these are the three main advantages, these are the three main characteristics. That was the decentralized, then obviously the decentralized and distributed, then the trustlessness, when n number of users are adding anonymous users, so how do we trust them and how can we do it, and the immutability of the transaction. So three basic things of the blockchain has pros also and cons also. So if we can see that whatever overlays, if cons overlays, then obviously we won't be using this. If pros overlays, then we would be using this particular technology. That's all for this video. In the next video, we would be discussing about the applications of the blockchain and how that particular applications are having the problem and how we can overcome by using the blockchain. That would be discussed. Thank you for this video.